All right, guys, this is the last video of the exponentials piece. Again, I'm wearing my same cozy because I'm doing these all in one day. This is the last one today, though, so I'm super pumped. All right, but I am still really cold. It's freezing in here. I don't know, it's like, I don't even know what temperature it is, but it's really cold outside. It's Sunday, and it's like raining out there and like really cold. Okay. And my heat is fine in my house, but it just is not warm enough for me. I know you guys don't really care. Anyways, let's get into the video. Okay, so today what we're going to be looking at are exponential word problems. Nobody likes a good word problems really that much, but I think these ones are good as far as word problems go, and they are going to teach you some life skills. Okay, here we go. At first I was nervous it wasn't going to pop up, and I was like, why? You've worked all day. Okay. So let's just minimize. Now I think you guys can see what I see. Okay. So reminder, our exponential function equation is that y equals a times b to the power of x, where a is our starting value, b is our base number, or bless you, base number, or like our common ratio, right? So common ratio, that's what we called it when we were doing sequences anyways. And then our x is like our term number, or what we're going up by, right? When we're doing this like generically, I always call this like our counter. What are we counting by? Okay, so we're going to start with some pretty basic ones, just so you guys can get the hang of how all of this works. And then we'll do one where it's a little bit more challenging. So example number 1, Jessica bought an iPad for $600 with her credit card and hasn't paid the bill. Oh, Jessica. Her credit card charges her 18% interest every month. 18% interest every month. Whoa. How much will Jessica owe after 3 months, after 8 months? Okay, cool. So first thing we need to know is, what is our starting value? So for this one, our iPad was purchased for $600. We're assuming she purchased this in Oregon and didn't pay any sales tax. Right? We're just assuming that her original purchase was exactly $600, and that's what she put on her credit card. All right, now we need to know our base number. All right, so this one says it's 18% interest. So we need to take that 18%. We need to divide it by 100. That's going to give us 0.18. And then our bill is increasing by 18% each month. They're charging us, so we're owing more. So this is an increase. So we're going to take 1.0 and we're going to add 0.18. And that gives us a b value of 1.18. All right, so that's how much we are increasing by, that 18%. All right, so then our b value 1.18. All right, now x isn't necessarily, when we're making our like generic equation, going to have a value, but we do want to take note of what our counter is. What are we going up by? And so for this problem, it says we're being charged that interest every month. So x is going to be the months that go by. So at month 0, we're at $600. Month 1, we'll then apply that first interest to it. Okay, so putting this all together to make the equation looks like this. Y equals 600 times 1.18 to the power of x. Cool, there's our equation. So now we can use that equation to answer the next questions. How much will Jessica owe after 3 months? So we know that x is counting by months, so we're asking for essentially what happens when x is 3. So we're just going to go through and plug that value in. Y equals 600, 1.18 to the power of 3. Head to our trusty calculator. 600, 1.18 to the power of 3. Oh, Jessica. She now owes $985.82. Right, I rounded a bit. It was 8192, so I just rounded to 0.82. All right, that is after 3 months. Let's take a look at what we owe now after 8 months. We haven't paid our bill. All right, y equals 600 times 1.18 to the power of 8. Jessica now owes a whopping $2,255. $2,255.32 because she didn't pay her bill for 8 months. It almost quadrupled. Pay your bills. Just don't get credit cards. Okay. Depressing but accurate. All right, next up. James bought a car for $18,000. Its value decreases by 15% every year. How much will the car be worth after 2 years, after 5 years? So we're going to do the same thing. I'm going to go over here. I'm going to say, okay, our A value is our starting amount. All right, that's how much our car costs now. That's $18,000. That's how much we paid for it. Our B value. All right, so this one says we are decreasing by 15%. Okay, decrease. All right, so first we need to take your 0.15 and, oops, spoiler alert, it's 0.15. So that 15%, so 15 over 100 is 0.15. And then it's a decrease. So we're going to take our 1.0, we're going to subtract 0.15, and that's going to give us 0.85. All right, so there's our B value. And then last but not least, we just want to make sure we know what our decreases is counting by. And it says every year. All right, so our X represents years that have gone by. All right, so X is years. Perfect. We're going to take all this information. We're going to make it into a nice equation. Y equals 18,000 times 0.85 to the power of X. Brilliant. All right, so there's our equation. Now we need to use that equation to answer our questions. All right, so after 2 years, that means our X value is 2, and we want to plug that in. So Y equals 18,000.85 to the power of 2. Head to our calculator. So after 2 years, our car is now worth $13,000. So if we wanted to sell it after 2 years, which why, we're losing about $5,000, right? And it's actually $13,005, like exactly, which is kind of cool. All right, let's see what happens after 5 years. Now, 5 years is when people start kind of looking for new cars. The average people keep a car is anywhere between kind of like 5 and 12 years, I think. I remember Googling this a while ago. But anyways, like between 5 and 10 years, people get rid of their cars. So 5 years is, I think, like the first time people start like getting rid of a car. So what are you going to get if you keep a car for 5 years? How much you're going to get for it if you're trading it in or whatever, right? So here we go. 18,000.85 to the power of 5 years. 7,986.70 if we round. So you're at $8,000, right? So after 5 years, you have, halved the value of your car plus some, right? More than half the value. So, maybe don't buy a new car. Okay. What's this one? Okay. In 2012, the Cupcakes Rule Fan Club had 307,212,123 members and was growing at an annual rate of 0.9%. Assuming this trend remains, what will be the expected number of members in 2029? All right, this is kind of like the last ones we did. We'll do it really quick because it's only, I don't know, they go pretty fast. All right, I'm actually going to say, I'm going to pause the video. I want you guys to see if you can do this one, and then we'll reconvene. All right, so pause. Okay, hopefully you guys paused and did that problem. If not, then you should have. All right, but anyways, here's the outcome. So your A value is that 307 million number. Your B value is going to be 1.009. X is representing your years because it does say an annual rate. That would be yearly. So then you have your equation, and you're then trying to figure out 2029, which 2029, subtract 2012 has a 17-year difference. So that means 17 is going to be our X value. Plugging that in, we get 357,775,029 members. Okay. Last but not least, we have example number 4. This is actually what I thought was the last example, but I didn't know that there was a number 3 in there. But this one's a little bit different. So I actually want you guys to try this on your own and then see how you do. So this is giving you your 2017 value of the car, and then it's giving you how much she sold it for in 2021. So it's not giving you the percent increase or decrease, and you have to find that. So I want you guys to take a pause and see if you can do that problem, and I'm going to do it on my end as well. Okay, so hopefully you paused. I paused too, and I kind of just set up the equation. So hopefully you were able to get to this part. All right, so it gives us an A value of 44,990. It doesn't tell us B, and we do know that we are depreciating value each year. So we do know that X is years. Then it gives us the car was sold in 2021. So that's 4 years after the 2017 purchase. So when X is 4, we know that we sold it for 33,654.86, which is a Y value. So it's essentially giving us an X value and a Y value. So I'm making my equation. I don't know B, but I do have a value to plug in for X and Y, which is what we've got right here. So now we're at the solving stage. All right, so now we want to go ahead and we are trying to solve for our B value. So we're going to go ahead and divide by 44,990 on both sides. All right, so we've got 33654.86 divided by 4499. All right, that's going to give us 0.74805 equaling b to the 4th. All right, we need to undo the b to the 4th, which means we need to 4th root, or you can take the 1/4 of both sides, right? Raise it to the power of 1/4. All right, most calculators, that's going to be the fastest way to do this, right? 4 to the 1/4 is going to cancel. And so I'm just taking that answer and then I'm raising it to the power of 1/4. Enter. All right, and I get 0.9300000005. So I'm just going to say 0.93 equals my B value. All right, so I have a B value. Now this is not answering any part of the question because the first part of the question says what percentage did the car depreciate in value each year. Right now what I have is Y equals, and then I've got my A, 44,990. I do now have my B and to the X. So this is my kind of like explicit equation, right? But I don't have the percentage that I depreciated. I just have the B value. So we do need to calculate that kind of separately. So to find our percent increase or decrease, we know that it's a decrease because it's less than 1.0. So we're going to take 1.0, we're going to subtract 0.93. That's going to give us 0.07, and then we're going to multiply that by 100 to get 7%. So we have a depreciation of 7%. For this problem. So we are depreciating, or we can say decrease, right, by 7%. Okay, so that's part 1 of the problem. And then the second part says, what would she have made if she sold the car in 2020? So this is asking us, so we know what she made in 2021. That was 4 years later. So really we have an X value of 3. And we want to see what we would have gotten. So Y equals 44,990.93 to the power of 3. And let's see what she would have had. So 44,990.93 to the power of 3. She would have sold it for $361.88. All right, so that means she would have made what? Roughly $3,000 more if she would have sold it a year earlier. Maybe it would be worth it, maybe not. Okay, so that is word problems. All right, hopefully that was helpful. If not, sorry about it. You know, I did what I could. But this should be our last video in our exponents and the exponentials part of the unit. The next videos are going to center around the inverse of the exponential, which is your logarithmic function. All right, but you should now be able to do all of homeworks 1 through 4 and complete that check-in kind of at the end. Hopefully you do well. Hopefully if you were AP testing, you did really good. If you weren't AP testing, then hopefully you use your time wisely. All right, guys, until the next time, bye.